we're going to be deriving the quadratic formula using completing the square. Now we have a general quadratic equation. What I mean by general is that it's not specific. It doesn't have certain numbers. The a, b, and the c actually represent any number. Those could be any numbers. They're variables. They're also coefficients or numbers in front of my terms. So if we find the general case of a, b, and c here, and we can solve this quadratic problem right here, this quadratic equation, we can actually find a formula that can help us solve it every time. We can't always factor quadratic equations, and so we've been getting used to using completing the square. But if we don't always want to complete the square, there's actually a formula we can figure out by using the general case and completing the square for the general case of our quadratic equation. So if we can get this in a form where it's x plus something squared, if we can make this a perfect square, so if we can get it into x plus any number, I put a smiley in over there, but some combination of these coefficients, the a, b, and c, squared, equaling to some other number, some other combination of the a, b, and c, then we can solve it. If we have a perfect square equal to a number, we can just take the square root of both sides, so we get x plus our combination, our smiley face, equals plus and minus the square root of our flower or our other combination of numbers. When we get this, we can actually solve to see what x is. So x is equal to, we're going to subtract a smiley from both sides, a combination of numbers from both sides. We can get x is equal to our smiley, which is a combination of numbers, plus or minus the square root of our flower. So this is the general idea of what we're going to do to this quadratic equation in order to come up with a formula that we can use every time to solve every quadratic equation. So let's start with our general case. A squared plus b squared, ax squared plus bx plus c is equal to 0. Now the first thing that we're going to do is we're going to divide by the coefficient in front of the x squared. So we're going to divide by a. So each term by a. And so we get x squared plus b over ax plus c over a is equal to 0. Now we're going to subtract our c over a from both sides because right now this doesn't look like a perfect square. We're trying to make this side of the equation be a perfect square. So subtract ca from both sides, and I'm going to leave a little blank right here in order to fill in what's going to make this a perfect square. So I have x squared plus b over ax is equal to negative c over a. I've just subtracted c over a from both sides. Okay, so now we're ready to try and make this a perfect square, and this is the part that's a little bit tricky for most people when they're doing completing the square. So we're going to take whatever half this is and square it. Now if we do that, we can get a complete square over here. We have to remember though, we can't just add it to this side. We also have to equal it out. This is an equation after all. We can't just make this side heavier or lighter. So we're going to take b over a. We're going to take 1/2 of b over a. So 1/2 times b over a is b over 2a. So we're going to take that b over 2a. We're going to square it because we want a perfect square, and we're going to add it to both sides. So plus b over 2a squared, and we also have to do the same thing over here, plus b over 2a squared. Now we can factor this. This is what our perfect squares look like. So we can factor this, x plus b over 2a squared. If you were to take that and use the distributive property, you would get right back up to this one over here. So this is our perfect square. This is basically the definition of a perfect square right here. And so we've got x plus ba squared. That's just factoring this over here. And then we're going to go ahead and square both terms on here just to simplify that a little bit. So we have negative c over a plus b squared. Since it's the whole thing squared, we just square each of those. B squared over 4a squared. So now we're going to simplify this side just a little bit. We're going to find a common denominator. So a common denominator here, we need something that both of these will go into, that are factors, that's a multiple, the least common multiple of both of these. So we have 4a squared here, and we just have an a right here. So if we have 4a squared, we're going to multiply this one by a 4a. Now remember, we can't change the value of this, so we have to multiply both the top and the bottom by a 4a. So if we do that, we get a negative 4a, the negative comes from that c, a negative 4ac over 4a squared plus b squared over 4a squared. Now we have a common denominator. Our common denominator is 4a squared. When we have a common denominator, we can just write the terms over the common denominator. So this stays the same. X plus b over 2a squared is going to give us negative 4ac plus b squared over 4a squared. We're getting closer. So now it looks like our smiley face and flower. So if we have a smiley face, this is our smiley face right here, a combination of those, and it's equal to our great big huge flower over here. And now we can solve just by taking the square root of both sides. So if we take the square root of this side, it's equal to plus or minus the square root of everything over here. So negative 4ac plus b squared all over 4a. Now we're going to take the square root of something squared, and that's going to give us just x plus b over 2a. And that is equal to plus or minus the square root of the numerator over the square root of the denominator. Remember, we can, when we have a fraction and we're taking the radical of it, we can take the square root of the top over the square root of the bottom. So we've got square root of the top over square root of the bottom. And so then I'm also going to be subtracting a b over 2a because I'm trying to solve for x. Remember, the square root of 4a squared is just going to give us 2a, still down in the denominator. So subtracting a negative b over 2a from both sides and simplifying our denominator over here, we get negative b over 2a, we subtracted that from both sides, plus or minus the square root of b squared minus 4ac. Also notice from here to here, I rewrote it. I rewrote negative 4ac plus b squared. I rewrote that as b squared minus 4ac. It's the same thing. I just rearranged the terms to look like what we know the quadratic formula is written conventionally as. And that's all over 2a. And we are just about finished. So sometimes mathematicians leave it just like that. They leave it over so you have two fractions, but oftentimes you will see it written as over a common denominator. So that's all we're going to do here is take the common denominator. So I have x equals negative b over 2a plus and minus the square root of b squared minus 4ac over 2a. That's my common denominator. I already have a common denominator, so I'm just going to write my terms over the common denominator. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you can solve any quadratic equation and your problems are all solved, at least if they're a quadratic equation.